Hi, and welcome to Secure Cloud Managed Branch Demo. This demo will help you show aspects of the Meraki solution that make it highly suitable for deployments in remote branches. We will discuss how to securely connect a branch via WAN by using AutoVPN and SD-WAN. We will learn how to protect the network and the clients through a layered security approach, and we will discover how the intelligent assurance features help with remote troubleshooting. We will do this through three scenarios: secure WAN, secure access, and operational efficiency. To get to this demo, in Cisco dCloud, search for a secure cloud managed branch, and then click on View to get to Meraki Launchpad dashboard, which you will be using for this demo. In scenario 1, Secure WAN, we will show how to leverage AutoVPN to create secure WAN connectivity between a branch, headquarters, and other sites. We will demonstrate how to use inbuilt WAN monitoring capabilities to determine the performance of established WAN links, and finally, how to use software-defined WAN to assure good performance for business-critical applications. In Meraki Launchpad environment, the San Francisco network is the network of our headquarters, and we have several branches in London, New York, San Jose, Sydney, and so on. We wish to securely connect London branch to our San Francisco headquarters using AutoVPN. AutoVPN is a Meraki feature used to provision site-to-site VPN tunnels. What's great about it is that it makes configuring VPN very simple. AutoVPN is configured under Security and SD-WAN, Site-to-Site VPN. A site could be not participating in VPN at all. It could be configured as a hub, meaning they will establish VPN tunnels with all hubs and dependent spokes. Or in our case, it's configured as a spoke. Spokes never create tunnels amongst themselves, and you have to explicitly define which hubs they will connect to. In our case, London spoke forms 3 VPN tunnels, to headquarters in San Francisco and to 2 data centers. The only other setting that we need to configure to establish the VPN connection is choose which local networks shall be advertised over VPN. In other words, which of these pre-configured subnets will be reachable from other locations. AutoVPN will use a system called VPN registry to establish the VPN tunnels and populate the route tables of each participating MX with the routes to advertised subnets. We can examine the route table for our London MX by going to Security and SD-WAN route table. We're interested in routes that are originating through VPN, so we can go ahead and filter by that type. And here we can see a number of routes to Sydney network, for example. Now, Sydney is a spoke as well, so we do not have a direct VPN tunnel to Sydney. Instead, we can see that all of the traffic to those subnets will be routed via our hub in San Francisco. And that makes sense, because San Francisco as a hub has VPN tunnels established to both London and Sydney, which serves as spokes. By examining the route table, we confirmed that VPN registry has successfully distributed the routes, but to check if the VPN tunnels are up and running, we use the VPN status page. Now, there are in fact 2 VPN status pages that you can examine. There is an organization-wide VPN status page under Organization VPN Status, and this page lists VPN tunnels across all of the deployment, and gives indication of their status and connectivity, as well as usage and latency information. There is also a network-specific VPN page that you can get to under Security and SD-WAN VPN Status. And this page will list VPN tunnels that are specific to our London network, again giving information on usage and latency, but also giving this section about uplink decisions. Most MX security appliances have 2 WAN uplinks, and if both are connected, AutoVPN will in fact establish redundant VPN tunnels to every destination using both of these links. And that is the basis for SD-WAN, which is an engine that chooses which uplink will be used based on the SD-WAN rules that we set. Let's first have a quick look at how our WAN links are performing. Go ahead and click on either WAN 1 or WAN 2 in this table. I'm going to open it in a new tab. And this brings us to the uplink performance page. Go ahead and click on all so that you can see the performance of two links side by side. WAN 1 seems to be performing quite well. There's some latency, a bit of a spike here, very good jitter and very good loss. WAN 2, however, we see a pretty high latency, um, jitter which is worse but okay, and pretty high loss of 28 even to 37%. If we compare the MOS scores, we can really see that WAN 2 is at the moment not good at all for applications such as IP telephony or video calling. Now we have a telepresence unit at our London branch. We want to make sure that telepresence unit will use the WAN link with a good MOS score at any one time, or at least the WAN link with the better MOS score out of the two. If you go to network-wide clients, you will be able to see that we have a telepresence unit which uses an IP address from .25 subnet range. Let's go ahead and examine the SD-WAN rule that applies to our telepresence unit. Go to Security and SD-WAN, SD-WAN and Traffic Shaping. And down here, you can see a number of custom performance classes. For each class, we have a set of performance metric limits which define what is considered good performance for that class. For our telepresent traffic, we will consider that the performance is good if the maximum latency is less than 10 milliseconds, maximum jitter is less than 10 milliseconds, and maximum loss is less than 5%. Here is the SD-WAN rule that applies to our telepresence traffic. Let's go ahead and examine that. First, let's have a look at the traffic filter. The traffic filter defines which traffic this rule will apply to. Let's go ahead and click on the filter, and here you can see that it is defined so that any traffic originating from our telepresence subnet will be subject to this SD-WAN rule. Under normal operation, we want to use WAN 2 for telepresent traffic, probably for load balancing purposes. But if the performance is poor, we want it to fail over to the better performing WAN 1. And the performance is poor based on the performance class telepresence, which we have defined earlier. Let's have a quick look at SD-WAN in action. So go back to the VPN status page, and let's look at the uplink decisions for our .25 telepresence subnet. And here indeed we can see that the uplink decision is WAN 1. It is a performance-based decision. And we're using the preferred WAN 2 policy based on the performance class telepresence. And this brings us to the end of our first scenario in this dcloud demo, where we have seen how to securely establish a WAN connection to a branch using AutoVPN, and then how to use SD-WAN to assure performance for our business critical applications. For scenarios 2 and 3, check out other videos in this series. Thank you and happy demoing.